Find the number of zeros at the end of 173 factorial. So basically, we need to find the number of pairs of 2 and 5, which is actually the number of 5s. If we can count the number of 5s, we can get the number of zeros at the end of 173 factorial. So let us try to count number of 5s here. Now this is basically a clever process. You can count easily by just writing all the numbers by which 173 factorial is made up of and then seeing how many 5s are there. Or you can just be a bit clever and see how do we get a 5 actually. Now I know that I can get a 5 through a 5. Now we'll talk about the numbers up to 173, because 173 is the multiplication of all the numbers starting from 1 up to 173. So first 5 I'll get from 5 itself, then another 5, let me write it down clearly. First 5 I'll get from a 5, second 5 I'll get from a 10, third 5 I'll get from a 15, and then 20, and then 25, and then 30, and so on up to the last number that is lesser than 173 but divisible by 5. That will be 170. But there is a problem here, because 25, numbers like 25, they won't give me just one 5, they will give me 2 5s. So let's say that in this series here, we have counted 1 5, that since it is a multiple of 5, it gave me 1 5 and we just counted that. Now we are left with one more 5 that we need to count from that I'll get from this 25. So now let me write down the multiples of 25. So first multiple of 25 will be 25 itself, and then I'll get a 50, and then 75, and then 100, then 125, and then 150, then 175. But I won't take 175 because 175 is greater than 173. Now each multiple, all the numbers written here are multiples of 25. So apart from 1 5, because they are the multiples of 5 as well, so we have already counted them here, and we have thought that they will give me 1 5. But here they are giving me one more 5 because they are multiples of 25, and 25 is 5 times 5. So they will give me one more 5 for sure. So actually like, see, this is 5 times 5. 50 is 25 times 2. So this is 5 times 5 times 2. This is 5 times 5 times 3. 100 is 5 times 5 times 4. 125 is 5 times 5 times 5. And 150 is 5 times 5 times 6. Now all the numbers contain 2 5, but one of the 5s we have already counted here as a multiple of 5. This 5, this 5, this, and this we have already counted when we are counting the multiples of 5. So in this we'll just count one more 5. So like we'll just take this 5, this 5, this 5, one more 5, one more 5, and one more 5. So we'll again have 1, 2, 3, 4, 5, 6. We'll get 6 more 5s from here. Now you might be wondering that, okay, we have an extra 5 written here, so what about that? So that will come when the number is a multiple of 125, because each 125 will give me a third 5. 2 5s I have already counted, this 5 as a multiple of 5 and this 5 as a multiple of 25. So I have one more 5 which will actually come in all the multiples of 125. So let me write that down. So I have here 125. Next multiple will be 250. But this is greater than 173. So I won't count that. So I'll get one more extra 5 from 125. So now let's see how many 5 do we have here. So this first series here, how many 5s can I expect here? So let me divide 170. Let me divide 170 with a 5. So 5 3s are 15, 5 4s are 20. So this will give me 34 5s. 34 more 5s. I'll have 34 5s from here, 6 more 5s from here, and 1 more 5 from here. So altogether I'll have 34 plus 6 40, 40 plus 1, 41 5s I'll have in this 173 factorial, and number of 2's will obviously be much greater than 41. So I can say that the number of pairs of 2 and 5 will be 41. So this number will have 41 zeros at the end of the whatever this product will be. And I think now it will be pretty much clear. How do we count the number of 5's? Each multiple of 5 will give me 1 5 at least. Each multiple of 25 will give me 2 5's. But since I have counted 1 5 already as a multiple of 5, so I'll just count one more 5 in all the multiples of 25, which gave me 6 more 5's. And third is multiples of 125. They'll give me an extra 5. Actually, they'll give me 3 5's, but this I have already counted as a multiple of 5. This 5 I have already counted as a multiple of 25. This 5 I'll count it as a multiple of 125. So this gave me one more 5. And all the numbers will reach up to all the numbers that are lesser than or equal to 173, not beyond that. So altogether I'll have 41 5's, which will give me 41 zeros at the end of 173 factorial.